Right, sorry about that. Right, welcome everybody to this talk on building AI solutions with Semantic Kernel, which is Microsoft's sort of platform for building AI solutions. If you've looked at something like LangChain, it's kind of the .NET equivalent for doing that. So if you're coming from a C# background, you'd probably want to use Semantic Kernel. Really interesting bit of technology. I think it works a bit better than LangChain. It's pretty simple to use. We can do some pretty interesting things with it. So I'm Bill Ayres. I've got various qualifications from Microsoft over the years, including the AI 102 and the AI 900 certifications, which I didn't actually take the exams for because I do the exam questions. So I've been doing AI for quite a long time. I mainly talk around Office 365, Microsoft 365, and the various Office products and things around that, and extensions development for that. So I spend a lot of time coding in JavaScript, but I do occasionally work in C# as well. So excuse me if I look a bit clumsy when I'm in Visual Studio, because I'm used to Visual Studio Code, and I'm kind of wondering why it won't compile because I'm using TypeScript instead of C#. And there's my contact details if you want to follow up, if you've got any questions. I've got a blog of sorts as well, but by all means follow me on Twitter, as I continue to call it. So we'll look at, first of all, around the state of the art in machine learning, and then we'll talk a little bit about transformers and how they have really revolutionized machine learning and AI, particularly around natural language processing, but also in other fields as well. Then we'll look briefly at Azure OpenAI. We'll talk about how large language models work, and then we'll build our own ChatGPT kind of application using Semantic Kernel and see just how easy it is. And then we'll talk about how we can orchestrate and build more interesting things and build things with agency as well, which will actually do things as well. So I hope it'll be interesting. So first of all, I did this slide. I used this when I was doing talks on AI in around about 2017, 2018, when it wasn't fashionable yet. And at that point, speech recognition and image classification, which were two key areas of machine learning and artificial intelligence, had just got to the stage where they were below 5%. This dotted line here represents 5% error rate. And it was actually Microsoft with their ResNet, I think it was ResNet 152, was the one that actually made that breakthrough for image classification. So you throw in an image and it gives you a description of it and say, I can see a dog and a cat and a bicycle and so on. Now, only a few years earlier, like 3 or 4 years earlier, the error rate of these models was 60%, 30% for image classification, which meant it was utterly useless for any practical purposes. Interesting for research, but not really useful. But once it gets below 5%, 5% is significant because it's the human error rate. So once these models became better than human beings at doing things like image classification and speech recognition and translation, language translation, it was a game changer. It became something that you could use for practical applications. So everybody got very interested in it. And we could do things like, for example, this was in Azure AI Vision, still available. It is a more traditional AI model. We'll see how it works in a second, but you can throw it an image and it will come back and say, yes, I can see it's a black and white photo of a city. It's got a city, a few random words in there as well, large white building in a city. Not bad, useful enough to generate usable captions. So, for example, if you had an image database of 10,000 images and you wanted to classify them and nobody tagged them, you could throw them at a model like this and it can give you useful information and allow you to find things. This is what's called weak AI, in that it's very application specific. It does one job. in no sense does it understand what a city is, or what a building is, or why a building would exist. It just can see images and produce captions and tags for them. And they were using techniques like convolutional neural networks. So a convolution algorithm is where you go and you might use it, say, in your Photoshop. You might want to sharpen an image or add artificial blur to an image. It will go and visit each cell or each pixel and look at the surrounding pixels and do some averaging or some computation on each one to do things like edge detection and enhancement and things like that. And that's what these networks did. Very complicated. This is only the half of it. Very complex neural network which would have these layers which would break the image into sections, scan them, combine them again, do softmax across them, pool them, and it eventually gets down to smaller and smaller little image fragments that kind of mean something. And at this point, we don't really know exactly how it works. We just know that we can detect features. So they might be vertical lines, circles, it could be anything. And then there's another few layers that look at those features and say, okay, I can see a flower or a butterfly or a cat or a dog. And you can train these models to do it. And that was very successful. And it meant we had, quite reasonable image classification models. But it wasn't good enough to do something like, if you want to do something very specific, like say, what butterfly species is this? It wouldn't be, it could, when I first started this, it couldn't even say it was a butterfly. It would say, this is a flower or something like that. Eventually, it got better and it would say, now if you ran that model, same kind of model, but improved versions, it will probably say, I can see a butterfly, but it couldn't tell me what species it was. I'm going to take a guess that most people in this room couldn't tell me what species this butterfly is either. I will tell you later. But that's more specialized. And so what I would have to do is build a custom vision model to do that. And I'd use a technique called transfer learning, where you take this neural network and you take the last few layers away and you retrain those and keep everything else frozen. And you can get without too much effort, you can get a pretty good classifier for specific things. And that's quite a nice application. You make a custom image classifier, which is great. And it can do object detection as well. And it will say there's one here and there's another one here. And those models actually work very well for specific things. Now, when it comes to natural language processing, you need a slightly different model, because whereas an image is kind of a two-dimensional set of pixels and you work your way across finding each pixel and its neighbors, in the case of a text string, it's sort of the text string is like a linear string of tokens. Usually they're broken down into text tokens. It might not be a whole word, it might be a fragment of a word. And you have to have a way of looking at that stream and then going back. So the neural net has to go backwards and forwards and look at what's happened previously in the string in order to try and get some meaning out of them, because the meaning of words depends on the context and what's around them. So these recurrent neural networks did a reasonable job. They could do things like in Azure Language Service, for example. There are tools for doing things like doing sentiment analysis in natural language, or finding keywords and key phrases in there, entity extraction from it. That's very useful if you've got an application where you've got a lot of data and you want to extract entities like product names or something from a lot of data. So there are useful applications for this. So recurrent neural networks were okay for doing this kind of job. But then came along a breakthrough paper in 2017 where some Google engineers published a paper called "Attention is All You Need." Attention in this context means the way that in natural language processing, text processing, it will focus on a particular piece of the text and the things around it. So that's the the attention, and it would use this technique. And you know, there are scientific papers about how it works, but it has these multiple attention heads that can look at different bits of the text string and relate them to each other and extract meaning from them. And by training them on huge amounts of data, you can come up with some very good natural language processing, text processing models, which are far better than we could with the recurrent neural networks that we used before. So this famously was used in GPT-3, Generative Pre-trained Transformer version 3. There was a GPT, earlier versions. GPT-2 wasn't very good, but GPT-3, they just got to a sort of a breakthrough in terms of how good it was in terms of text processing, and it was starting to give you back reasonable sounding answers to questions, and not all the time, but it became very interesting. That then became GPT 3.5, which was an enhanced version of that specifically for building a chat interface, and that's what was published as ChatGPT, at which point everything went mainstream because people were just amazed, and kids started writing their homework using it and things like that. So this is where things got really interesting. What happened to the monkeys? And that was a cartoon in private eye. So it's mainstream now, but up to GPT-3, it was kind of an interesting from an AI research point of view, but it's really become mainstream. And it's because of these transformer models. Now, Azure AI Studio, Microsoft did a deal with OpenAI, who developed this, the GPT models, and that will, you know, you can use that, and I'll just show you what Azure AI Studio looks like, assuming I've got a reasonable internet connection. So I'm going to go to portal.azure.com, and you have to, when you sign up for Azure OpenAI, you have to go through a gating process. They don't, you know, even if you've got an Azure subscription, you won't be able to create an Azure OpenAI resource in Azure. You'll have to go through a process of being approved, and then you can create this Azure OpenAI resource, which then comes with a couple of studios. There's the old one, Azure OpenAI Studio, and this new one, which is Azure AI Studio, which doesn't just have the Azure OpenAI being the company behind GPT, but all these other models like Llama and some of the small language models, which are actually turning out to be quite interesting, because these large language models like GPT-4, which is the current version of it, are really quite expensive to use. So sometimes you can use a small language model to do what you need to, and that can be more efficient. So it's good to have choice. So that in Azure, you now have a choice of multiple models that you can pick through. You know, a lot of them are models from Hugging Face and these other suppliers. But if I go to, let me pick GPT-4, and you can start playing around in here, and it's just a sort of playground, so you can work with these models and see how they work. So it's a bit like using ChatGPT, and I can say, I don't know, what shall we ask it? Who won the World Cup in 1966? And it will interact with us. So you can then do things like you can go in here and say, this is the system message, which is that's the message that goes into every prompt that goes into the system. But we can also add other things. So there are ways of, in here, we can, for example, one popular thing, which is the RAG, which is Retrieval Augmented Generation, is you can go in, and if you've got something like, for example, Azure AI Search, you can connect to that and get Azure AI Search to process some documents and then use that. It'll use that as the input to the model. And we'll see how these different things work a little bit later. So that's the Azure AI Studio, but you do have to sign up for it to get access to it. So these large language models, all they do essentially is they do completions. So you give it a string of text, and the underlying large language model, sometimes they're called foundational models because they underlie a chat system, for example, or a chatbot. You give them a string of text, and it'll try and predict what the next token will be, which might be a whole word or a fraction of a word. And that's essentially all they do, and they just do that over and over again. So it's a bit of an illusion that it looks as though they're intelligently asking your questions. It's just predicting what would come next. And it is surprising that something that is inherently so simple can be almost like, having a conversation with somebody. So you start with some tokens. So this is what the token, it's a bit small this, but the tokens are, for short words, they might be the whole word. For longer words, I didn't see one here. The numbers here are broken up, for example. And it will then feed it into the model. And then it looks at a probability and says, what's the probability distribution of the words that could follow this? And you can adjust some parameters. So in the Azure AI Studio there, for example, I could tweak some of the parameters and say I want it more creative, in quotes, or less creative, and that will limit the range of the probabilities of the predicted next character. So even if you set that temperature variable quite low to say it's going to be very predictable, you still don't know exactly what's going to come out everywhere. So it's a bit of a nightmare for doing demonstrations because you're never quite sure what's going to come back from the model. There is a non-deterministic element to it. So basically, it's tokening. Oh, sorry, hang on. Tokens in and then tokens out. Here's an example of if we were up to here, we need to stop. What's the next character? Then one possibility is a fragment of the word anthropomorphizing, and once it got to there, it would probably come up with, it's got to come up with something that makes sense from we need to stop anthrop, and then once you got to anthropomorph, you've kind of pretty much got to add ising on the end, and then it will say what's next, maybe chat, and then it will chat GPT. All it's doing is generating the next token and predicting what it's going to be. So this is what it looks like as it kind of builds up the string. So it's inherently, it's trying to complete a text. So that on its own isn't actually that useful if you want to build a chatbot or something like that. And this is just looking at the different probabilities of different things that it can add to the end of the string. So one of the things you can do with these large language models is you can retrain them in the same way. If you remember, I mentioned that the vision model, you could retrain it by transfer learning to solve some specific problems. So what if I want to build a chatbot to do something fairly specific, which is a very common application? It's great that it knows who won the World Cup in 1966, but if I want to do things about my business or some particular field of application, like the medical profession or something like that, I need to do more to make a useful chatbot. So one approach is prompt engineering. So you can give the model some instructions, and so you can tell it things like, I want you to give me the output only in JSON, or it's got to be rhyming, make poetry, or you can give the model instructions and it will read those, and that is just all part of the completion. That's all that's happening, is your instructions to the model are forming part of a prompt which it then tries to complete. The prompt might be, we can say, give it some instructions, say, translate this code. So if we were inside GitHub Copilot, for example, the prompt might look something like that. They're not going to tell us exactly what the prompt is because that's their proprietary information. That's how they get GitHub Copilot to be effective, but there will be something like that in the prompts. Or we might just give it, another thing is you can just give it a completion and say, give it the first sentence or the first 10 words of something and let it go on. So it was a dark and stormy night, and see what it comes up with. It might come up with some nice fiction, or you can ask it a question and say, what is artificial intelligence? And it'll go off and it'll answer the question, but what it's really doing is just doing a completion of the text. And yet you can make, just through prompt engineering, you can make these models quite effective and do a good job. And there are various techniques you can use. There are whole talks about how to do good prompt engineering, but one of the basic things is you just regard it as somebody who just isn't that well trained, and you just have to give them, the more explicit instructions you give it, the better, and the better the completions will be. So that's one technique. There is something called the system prompt. I actually saw that when I was in the Azure AI Studio. The system prompt is slightly different from the user's prompt. The user prompt might be, say, in my case, it was who won the World Cup in 1966. That's the user prompt. The system prompt was something like, you are a helpful assistant. I can't remember exactly what the prompt was. But the difference with a system prompt is that the chatbot puts that back into the model every time. So you get a different user prompt, but the system prompt is always there. It's kind of make sure it's always there. You can have history running. I will see how to do that in Semantic Kernel. But you can have the history so that up to a certain limit, all of the conversations so far is included as the prompt. So as you have a conversation, it each time gets fed into the large language model, everything that went before, plus the system prompt. Now, up to a point, because there's a size to that window, and eventually it gets exhausted and it forgets things, but it doesn't forget the system prompt, because that's put in every time. So so the system prompt might be, you must answer in rhyme, and then the user prompt would even if it didn't know the answer, it would have to come back and answer it in rhyme, because the system prompt has generated that. There is a notion in natural language processing called embeddings, which are big vectors of words. And so we saw the tokens, but they then get interpreted as these vectors, which actually contain the meaning of the words. So sometimes you get two words that are synonyms, not synonyms, homophones or homonyms, two words that mean two different things in different contexts, but they're spelt exactly the same. So that, the model has to be able to distinguish between them. So it will store this in this sort of multi-dimensional vector space, the actual meanings of these words, and they're quite interesting. So that they don't make much sense as numbers, and you can't really draw them pictorially because there might be hundreds of dimensions, but they will contain the meaning. So things that have similar meaning will be close together in this multi-dimensional vector space. So you can use that to process content and do a sort of semantic search where you look at the question or the prompt that the user sends in, and then do a semantic comparison against what's in a search index that's been stored using these embeddings. So that's how it's able to extract meaning from these sentences. But of course, it's been trained on these large language models have been trained on these huge corpus of content, and so they've gradually over time extracted the meaning, rather as a child learns by listening to people talking what the meaning of words is. The same sort of process, but at a huge scale, and it's horrendously expensive to do as well. So for GPT 3.5, so this is the ChatGPT model, they first of all took the foundational model, which was GPT-3 or some slightly later, some version of GPT-3, but they also, so that was the pre-training. So all of the internet, pretty much all the internet and GitHub and Wikipedia and Archive, which is an academic papers database, and all the books it could get hold of, and it was the model was then trained using that. That uses a technique called unsupervised learning, which means you just throw data at the model and let it figure it all out. And eventually, these transformer models are so good that they will eventually, pick up the meaning of all these words and become very good at predicting either the next token or even a missing word from a sentence. But that's very expensive. That original training, I believe, cost about $10 million. It took them about 2 months to do. They've probably redone it many times since then, and then they've gone on to GPT. GPT-4, I think, is at least an order of magnitude more data, more input, and correspondingly more expensive to do. But then they did, to make a chat bot, they then used some supervised fine-tuning. So this is fine-tuning, which we mentioned, where you're sort of keeping some of the parameters of the model constant, but changing some of the others later in the neural network. And that was done with teams of contractors who would just be sort of giving or inventing, here's the prompt, and this is kind of what we'd expect to come back. So that it is more useful, more realistic, more like what you'd expect the answer to be. Then they did even more training again with, and this is all supervised learning because people are saying this is a good answer, that's a bad answer. Rank the completions. Here's 5 completions that it's done, which is the best one of them, which you like the best, and they pick the best one. And then there's another mechanism called reinforcement learning using human feedback, which does a similar sort of thing that is, again, lots of people being paid to sit in buildings, improving the responses and scoring the responses that come back so that the model gets better and better. And that's how you get to a point where ChatGPT is able to give these answers that actually make sense, and they're, most of the time they're useful. And but this is horrendously expensive, and with each iteration of these models, it gets more expensive. So fine-tuning is very expensive. Retraining the whole model is prohibitively expensive. Experience has showed that fine-tuning these models for some particular application doesn't actually work very well, because you lose the advantage of all this work that's been done in the past. So practically, that doesn't turn out to be such a good option. So what you end up doing is using techniques like prompt engineering that's very effective. We have a memory context window, which I mentioned as the chat develops, so you can refer to things earlier in the chat. So all of this happens, and then the prompt gets sent to the large language model, which then will do the completion, but there'll be some guardrails on it as well to do things like stop obscenity or racial or these sort of problematic things that people will inevitably try to do with these models. And it'll check that. It'll have guardrails on the input as well. So you have both guardrails input and output. So there's a whole set of mechanisms built around this model. So it's not just the large language model. That wouldn't make a very good chatbot. But by the time you've done all this fine tuning to make it a good chatbot, and then you build all this around it, you can come up with a pretty reasonable model. So let's build one using semantic kernel. So first thing I'm going to do, I've got some notes here so I don't miss anything. Right, so what was I going to do here? So I've got a, so come up all right, yeah. Is that visible at the back? Shall I just zoom that a bit? That doesn't leave much on the screen. It's got to get the balance right between having something on the screen and let's make that a bit smaller. Oh, I didn't mean to do that. Is it good? Right, okay. And I didn't actually mean to do that, but it's gone. Just figure out how to get it back. So I had to do a couple of things. So all I did here in Visual Studio is I did file new project console app, and I also added, what did we add? We added, let's look at the NuGet packages we got in here. So the main important one here is Microsoft.semantic kernel. Got 1.15 in this one. And there's a couple of others. I've got Azure AI, OpenAI, and Azure Core. I think I can't remember if I think I do need those two as well. So there's a few .NET packages we need to add, and then we can, once we've got those, I'm going to do using semantic kernel, using chat completion and semantic kernel connectors OpenAI. And then I've just built a console app. So it's builder, kernel, create builder. Now, if I was doing a web application, for example, I would be doing something like, you can do it this way and do var, I do var builder equals, what would be web application. I don't think I got the right using, and then that will be create builder, something like this. This won't compile, but and then I do builder.services.add add kernel or something like that. I think it's add kernel. So I'd be able to add that into and then do it as a web application. Some people do it that way, but I'm just going to do just run it as a pure console app. And then I've got, in Azure AI, I've got these deployments. So where's deployments? I already have this. I'm going to use this GPT 3.5 Turbo one. So I've deployed this into Azure OpenAI. You can also do it through OpenAI. If you've got an OpenAI account, you can do the similar thing in OpenAI's service and use that, but you'll need to get a key from them. I'm actually using, hope it doesn't show the key. Please don't show the key, no. So I'm using one of these keys, and this is my endpoint. So it's the name of my resource that I've provisioned in azure.openai.azure.com. So that's what I'm going to use. But as I say, if you don't want to use Azure OpenAI, you can use OpenAI, or you could use some other model as well. There are other large language models supported. So that's I'm getting the deployment name endpoint. Deployment name is actually GPT 3.5. The endpoint is that flowsimai.azure OpenAI, and the API key is that secret that I'm not sharing with you. So then I can say builder services, add Azure OpenAI chat completion. And if I do that, you can see you've got a lot of options here. So I got audio to text. This is the one I'm using, OpenAI chat completion. I can use Azure OpenAI text to audio, text generation, text to image. And there's also OpenAI text embedding, OpenAI text generation, OpenAI text to audio, OpenAI chat completion. Those are the OpenAI ones, not using Azure's OpenAI implementation. And there are others as well that you can, there's a few others that are built in. And then other large language models, you'd have to bring in some more NuGet packages to support them. So that's Builder services, add Azure OpenAI chat completion, and now I can use that sort of dependency injection mechanism they have. So I do kernel equals builder.build, and I just need to set up a few things. So I need to get the chat completion service. So that's chat completion service is kernel get required service, and then we pass the iChat completion service so it does the DI bit in the background and gives me a chat completion service. This I'll come back to what's going on there a little bit later. And then I've just got a loop. So I say console write user, user message is stored as console read line. I do a quick check here because I found a nasty crash if I pass it a completely empty string. So I'm going to check that here first. And then we're going to put it into this history object. I'll explain the history object later. At the moment, I'm not really using it. I'm just using it to input to the chat completion service method, get streaming chat message content, say sync, and I'm passing it the history, these settings, which I'm not really using at the moment, and then the kernel object. And then I can loop through the response. So I'll send it off and then await, and then it'll start sending me the responses from the OpenAI GPT model, GPT 3.5 in this case. And then I can write it out. And I just temporarily put history clear here because I want to demonstrate something. So that's more for the purposes of the demo. So I'm going to save that. I don't know what I changed, but I'm going to run this. Okay, and so console app is running, and I can say, and if Kevin's internet connection is good, we can say, I'm going to say who won the World Cup in 1966? England won the World Cup in 1966. So that's, yeah. Okay, who won the World Cup in 2022? Okay. As an AI, I am unable to predict future events. The winner of the 2022 FIFA World Cup has not yet decided at the time of my last update of October 2021, because I'm using GPT 3.5, which is, that's when its training stopped. So it only knows things that happened up to that point, because that's when it's trained, when it's the data that it was trained on. If you go to GPT-4, it gets you up to sort of some time in 2023, which is a little bit better. So it's not great for current affairs. So let's see what else we can try. Let's say, let's ask it something a bit more obscure. What was Operation Mincemeat? Anybody know what Operation Mincemeat was?
If I remember correctly, it's when the corpse.
Yeah.
Somebody who was an officer.
Yeah, it was a deception in World War II where they left a corpse with some, and it's yeah, that's exactly what it's come back with. So pretty good for that kind of thing. So historical knowledge. Quite good. Right, I'm just going to tell it my name is Bill. Hello, Bill. How can I assist you today? And I'll just ask it another question. Who won the World Cup in 2018? Just to take its eye off the ball a bit. Okay. What is my name? I'm sorry, I don't have access to personal information. I literally just told you. I'm sorry, please could you tell me again? So the problem is that it doesn't have the history. So you need to put the history of the previous chat in. So that's what the purpose of this is. Let's fix that. So I've got history here. I'm going to enable history again. So that's what this thing does, is it adds the current message and the user message into the history, so that it's got a record of the previous conversation, and all of that will then get sent to the large language model. Semantic kernel takes care of all of this for us now from this point. So that should now work. So if I say,
further down, were you adding its response?
yes, yeah, they're both in. Yeah, so it's here. It's the user message, and down here, it's good point. Thank you. Yes, that's add assistant message. So that's saying this is what the large language model responded. So it's all going in there. So questions and answers. So now if I say my name is, and this doesn't always work. I should say something like, hello, Bill, how are you? Nice to meet you, Bill. Who won the World Cup in, I don't know, 2000? I don't think there was one, actually. It's held, most recent one was not held. The tournament was held in 1998. Right, now it's been distracted. What is my name? And it should go back through its, your name is Bill, as you mentioned earlier. So it's stored that, so you can see that from earlier in the chat. So now we've got a kind of a reasonable looking chatbot. Let's ask it what time it is. What time is it? I apologize. I don't have access to real-time information. Therefore, I don't know the current time. To know the time, you might check you might look at your watch. So we've got a. That's the next thing is there are things like very recent history, current affairs, or more typically in business, things to do with my organization or my particular field of knowledge that we typically need to know. So we've got another technique which is and there's one other problem, actually, another problem I want to mention. So we used GPT-3 to try and build dictionary definitions. And about 50% of the now this was admittedly GPT-3, which is quite an old model. We've tried it since on GPT-4, and to be honest, it's not much better. So GPT-3, half the answers were reasonable. Half of them were things like, baby moon, psychology, an experiment that presents itself over and over again, simultaneous subjective impressions. This is a good one. Babaco, a marine mammal with 6-headed spines, mainly used as a hunting device in the Philippines. A babaco is actually a type of tree, but the interesting thing about the completions that come back from a large language model is when they are wrong, they are completely wrong, and they are confidently wrong, and detailed as well. Definition number 2, a former British settler or expatriate who talks at length nostalgically about his or her former hometown of Manchester, England. Number 3, a place where drunken disorderly behaviour is tolerated, especially in public. That could be Manchester, actually. So, the problem is that the models, it's typically called hallucination, where they just come up with total garbage, but it sounds plausible and it's sort of confidently delivered. So this is a big problem with these large language models, is how do you ground them in relevant information? So that's the main motivation for doing this sort of RAG approach, the Retrieval Augmented Generation, where you, as well as doing all your prompt engineering, you use something like a search index or some other source of data, and then you feed that into the large language model. Now, you can't just go and, if you've got gigabytes of corporate information, you can't just throw that at a large language model. It'd be too expensive. So you have to have something like a search engine, do a semantic search like Azure AI Search, for example. Problem there is that isn't restricted, so you might expose information that somebody didn't have permission to see. So you might do something like in Microsoft 365 Copilot, for example. They use the Microsoft Graph to look at your company information, but it's all, in that case, it's all filtered based on what access rights you have to that information. So that's a slight problem. But otherwise, you use some source of data. But it could be that you just go to a database and retrieve some data, or you have some other application that some system, HR system or something that you can go to and ask for some data that's pertinent to the question, depending on what the question was, and then feed that back in. So there are various ways of doing it. So that's one way, is you do that. The other way, which is related really, is plugins, where you have some application, you write some code that just gives an answer to some questions. So I'll show you how that works. Probably the next thing we'll do is actually see that working. But there used to be they're sometimes called planners. These, how you tell the large language model to call this particular API to get this information. We now have something called function calling. So most of the large language models like GPT, Llama, and these other big models, they have this feature called function calling, where the model itself has been trained to look for functions or methods that it can call if you present it to it, if you present it to it in the prompt. So the function will be represented by some JSON string, which is a little bit like an OpenAI description, but more compact. Because remember, all these tokens, every time you send a token to the large language model, it costs you something. You have a limit to how much you can send. So you don't want these to be too big. So you want a reasonably compact description of your function. In this case, it's a function, a hotel search function. So the description of the function, so the system prompt, we call it meta prompt here, is you're an AI assistant to help users search for hotels. You should call search hotels function. You notice this is the sort of Pascal, not Pascal, so it sends that request in, and then the prompt will be whatever the user typed in: hotel with a private beach, cost max €300 in Del Maris, and it will then you'll get a response again in JSON from whatever this function is. Has to be sent back to the and then interpreted. So that's actually quite complicated to get that to work, but Semantic Kernel does all that for us. So I'll show that in this example of seeing what time it is. So we'll extend this now, and what we'll do is we'll say, let's create a function called time.cs, and we'll say namespace, I'm going to call it namespace plugins, and then in here I should have using plugins, shouldn't I? And then I'm going to say public class time plugin, and we'll have a method. We'll say public date time time, no arguments, and it's helpfully suggested that, which looks reasonable. Now, what I do need to do here, is I need to annotate this by giving it or decorate it with kernel function. So there's this attribute kernel function, and I'm also going to add a description, because this is how the large language model is going to know what this function does. So I'm going to description is gets the current date and time. So now that I've got that there, when I go to here, I need to, let's save everything we've done so far. What I need to do is now add the plugins. So there's you say builder.plugins, because this is the kernel builder, and we can say a few ways of doing it. We'll say add from type, and that I'm hoping it'll, yeah, IntelliSense will help me. In fact, GitHub Copilot helps me. So now, and that's it. There was one other thing we have to do, which is here, I've enabled auto-invoke kernel functions. So up until a few months ago, you would have various types of planners. So if you ever see anything on the internet about, oh, you should use planners, that's kind of changed now. We've moved on from planners. This does the planning for us. The planner means telling the model how to call the function and when to call it. And now we're going to use this auto-invoke kernel functions because the large language model knows how to do this function calling. And the key is that we've given it a description here. That should be fairly self-explanatory, but just to be sure, I've said there's a gets current date and time. Don't go mad here, because that's all tokens, so you don't want to expend too many tokens, but you want enough to tell the model what the function is doing. So let's restart this, and I'll just check that this still works. So my name is Bill. What's the time? And it's gone to that function, called it, got the value back, and it's done all that behind the scenes automatically. What is the date? It's pretty good. So it's same function call, but used a different part of the information that comes back from it. What is the day of the week? Ah, it's figured out that it's Tuesday. I'm not exactly sure how it's managed to do that, actually, because I tried this before and it didn't work, and I had to put a function in that said it's Tuesday.
Does it know what time zone it is?
Well, I think it's UTC now, isn't it? I can't remember. Was it UTC now? Or just now? No, it doesn't. No, I guess it doesn't. Well, it might do. It depends what comes back. Yeah, it depends what the date time string comes back. It just depends what comes back. Date time now is a string. We can just...
You're returning a date, you're not returning a string there. So
it is a date time. Yeah, it's a date time object. Yeah, it's a date time. I think so the date time object, it will deserialize it, and it's going to get everything should get everything that's in that date time object when it deserializes. Anyway, semantic kernel takes care of it so that it can use that information. Okay, so was there anything else I wanted to do in there? That was basically it. Yeah. Right, back to the slides. Because there's these just as a little bit of an aside, these there is now a GPT-4 Turbo with vision, where you can take a GPT format. So it turns out that these transformer models can also be used for image analysis. So it uses the same attention mechanism, and instead of you having to figure out, you know, like a 5-year research project, oh, we come up with this very elaborate convolutional neural network architecture. I'm oversimplifying, but the transformer model, the attention model, it kind of figures it out itself. So it means you can really scale what you can do with these. So you just as long as you can throw resources, if you've got enough GPU power at your disposal, you can come up with a good vision model using transformers. So here's an example of using GPT-4 Turbo with vision. So this model can also look at images, and it will come back with something like, remember the one before just said it's a black and white buildings and so on. This one is fairly descriptive of, oh, you can see the Empire State Building is prominently featured, blah, blah, blah. The descriptions are really, really good compared to what they were before with these simpler models. Prompt there was just, please describe this image. Interestingly, if I throw it this image that we looked at earlier of the butterfly, which we couldn't identify, please describe this image, same prompt. The image shows a close-up of a vibrant scene in nature with an orange butterfly on a purple thistle flower. Yeah, good, correct. And there's another butterfly, albeit out of focus. Quite a good description of the image, but because it's GPT-4, I can ask it a follow-up question. So I can say, what species is the butterfly? Second prompt, got this history as well. What species is the butterfly? It says, the butterfly in the image appears to be a painted lady, Vanessa Cardui. Binomial Latin description. Correct. It is a painted lady. So it's able to identify individual butterfly species, which I would have had to build a custom vision model for before. So it's really interesting that it's so much detail that you can ask a follow-up question and really get a lot of detail. So at this point, you know, I said that original, when we looked at the original CNN-based, convolutional neural network-based model, that it was weak AI. It didn't really understand what it was looking at. At this point, you have to ask, well, in what sense does it not understand? You know, what do we mean by understand? If not this, you know, if I can ask a follow-up question and it can answer it, then how is that different from human understanding, apart from the detail and the experience and the lived life and so on, which does rather, you know, make you question whether this isn't actually getting a little bit closer to artificial general intelligence, strong AI, rather than just weak AI and solving particular problems. Anyway, that was a bit of an, oh, and another aside is GPT-4 O for Omni, which was announced about a month ago. This one actually does not only the text, but it will do images and audio. So, you know, typically what we'd do if we wanted to do a chatbot that we talk to is we'd do something like we'd take a text to speech, speech to text, other way around, speech to text. So somebody speaks here, can't draw. Speech to text, you feed that to a large language model with all those other mechanisms around it to do the processing of the text. And then the large language model then comes back and we do text to speech. That's the right way around, yeah, text to speech. You know, that's how your, well, I was going to say how Alexa or Cortana or something like that works. Actually, they don't have such good language models behind them, and that's a cost thing because large language models are expensive. But that's the process that you'd use. So all the large language model gets is the text, but in the GPT-4o, the audio goes straight into GPT-4o, and then it also generates the the speech response. So it's getting more information than just the text. It's getting the tone of voice and the sort of the other sort of signals from who's speaking and things like that. And so if you ask it a question and you sound as though you're not being serious, the thing kind of giggles and then answers you. It's like Her, the film, and with was it Scarlett Johansson, wasn't it? It's much more like talking to a real person, which is a little bit frightening actually. So that's GPT-4o. On the other hand, I was a little bit disappointed with Outlook Copilot, which is one of Microsoft's Copilot products. Fairly typical use case. I hope you're doing well. I can get you 5-star reviews on Facebook, blah, blah, blah. I get about 10 of these a day. So I tried to use Copilot and said, reply saying no thanks. Copilot says, here is a draft response that you can use to reply to the email. No thanks. It's really helpful. You can copy and paste it into the response. However, I can't directly interact with your email or send messages on your behalf. Come on. That's exactly what I want you to do, is send messages on my behalf. So we want these models to not just give us text back. We would like to have some agency and have them actually do interesting things as well. So let's, what's one next one? Let's look at some more. Actually, I'll come back to this one. Because what I want to do is this demo actually, which is I want to make the model actually do something rather than just talk back to me. So I'm going to open another project, which is, let's close this one. You want to stop? Yes. I'm going to go to Busy Light. We're all right for a bit, aren't we, in time? So what we're going to do here is, so I have this gadget, which is a lamp. I was given this lamp to use with Teams. So this is supposed to go green if you're available and red if you're busy. So that was the. I work in an office on my own, so I don't really need to tell anybody whether I'm busy or not. I just ignore them. So I'll just plug that in there. And I found there's this library, a NuGet package called Complenom BusyLight SDK. So I installed that, and it turns out that can operate this light. So now what I can do is, I got a very similar chatbot to what we had before. I've just added a light plugin. So let's just look at the light plugin. So the light plugin has inputs and outputs. I've got another demo that shows inputs and outputs as well, but this one has, I've created a kernel function description, turn on the light with the required color. Not sure that was a very good phrasing, actually. Then I've also annotated the attributes or the parameters. So there's red, green, and blue. Now, it could probably, in fairness, GPT-4 certainly, I think, would probably be able to figure out what red, green and blue meant in this context. But it might not know what the range was. So I've said, added some description that says the percentage red color from 0 to 100, green and blue. And then what it'll do is it'll just get hold of this SDK. I've got a static instance here, and I'm going to call the SDK and set the red, green and blue. And actually, it took me a while to realize this, but for some reason, when they wrote this SDK, they put the colors in the wrong order. Instead of RGB, it's RBG. So I couldn't work out why the colors were wrong. So now that I've done that, I can call this. So this is going to work in the same way. It's a plugin, just as we had before, except this time I'm providing some parameters and it's going to actually do something. So now it gets interesting. So I can run this. So it will say turn on the light. Select this. Turn on the light. Actually, I was going to show you this earlier. I'm logging what it's doing, so I can disable this. Actually, we don't need that. So it's turn the light on. Let me just change this. That will go off again. I'm going to switch off logging. Don't want that at the moment. So turn on the light. Make the light blue. Okay. Let's try something a little more difficult. Make the light azure. Not bad. Knows what azure is. Make the light the color of grass. Okay. All right. Make the light flash blue. Okay, there's something I didn't have. Obviously, the large language model can't sort of act it through time. There's actually a feature in the light to make it flash. I did cheat a little bit here because I also added another function. So it has a light flash function where you say, give it the color and the time in tenths of a second from whatever the range is, 0 to 255, and then you can set it to blink. And then there's something in the light that flashes on and off. Clearly, the large language model can't keep coming back round. You'd have to have some mechanism to do that. What else can we do? We can say faster. It starts flashing faster. Because it knows, you see, it's got the history, it remembers. Okay. Make the light the same color as the shirts of the team who won the World Cup in 1966. Now, this doesn't always work because, so sometimes you have to do a sort of a bit of a chain of thought. So I can say, what color were the shirts of the, oh, I can't type all this again. Right, ask a question. The shirts of the team were of blue color. What? Okay, who won the, there's something going wrong here, Cup in 1960. I think it's confused because it is blue. England. What color were their shirts? And I've done this before and it says, what? let's, have we confused it by making the light blue? I don't understand why it's done this, because this is the problem with doing these demos with large language models. Right. Let's just do it. We'll do a chain of thought reasoning. So who won the World Cup in 1966? Damn you, GPT-3. England. What colour were their shirts? Otherwise, I think I'm going to blame Kevin's internet connection. Okay. Make the light that colour. Right, so we kind of got there in the end, but it's quite, sometimes tricky to get it to do a very complex thing, but it should be able to do it. I've got another example, actually, which I was going to show, which is, let me lose that one and open another one, which is, no, I think it's because we set the light to blue and then it just got kind of confused.
No, it's the same colour with America's response.
Yeah, it should know. Yeah, it should know that. It should know there are different spellings and map them to the same, that color and color map to the same semantic meaning. So that shouldn't, it's a good point, but I don't think that was a problem. But it's, yeah, well, at least it didn't make it white. What am I doing? Yeah, models, this one. I just want to open this one. And this is one where I've added a few more. So I've got a set of calculations here. So this is the one I was going to show where you're inputting numbers as well as getting numbers or information back. And this one's quite interesting because if you, so I've got these calculation functions, and I've got one for models, which is like a sort of a business application where I've got a set of data, very simple one. These are supposed to be different cars, and the cars are different colors. So there's the Jupiter and the Saturn and the Neptune and the Mercury, and they're available in these different colors. Products. Let's pretend they're cars. Well, we've gone into competition with Tesla, with our new car company, and these are our models. So that it sets up that dictionary, and then there's some methods here that say get the color for a given product SKU, get the length in meters, and get the size, and so on. So what I'll do is let's run this. So I can do things like I could have done this with the other one actually, because I've got the same models in there. So I can go and say got to select this. What is the what is 2 plus 17? Now let me just switch on the logging for this so we can see what it's calling. So I can say builder services add logging builder add console, and it'll, oh, hang on, I'm missing something here. What do I need? No, I want, let me use the other one actually. Have it in. Don't say that. Let me go over to here. This one should be set up to do this. So this has also got models and calc. Just check that it's got the plugins loaded. Yeah. So I can just put logging back on here, and we'll see what it does. So we say what is 2 plus 2? And it's gone and found this calculator add function. What is the square root of 2? Not sure why it did a multiplication, but it's got it right. What is the cube root of, now I've got the number written down here somewhere, so I know what it is. Which one is it? Yeah, 375, that's it, yeah. And I wrote down the answer, and we'll see if it's correct. Yeah, so the correct answer should be 7.2112. So way off, it's completely wrong. So it's used my multiply function. So it started guessing. It's hallucinated mathematics, which is pretty bad. But I can fix it surprisingly easily because under here I've got a function I've written which is for raising powers. So with a bit of luck, and there's no guarantee this will work, just by saying raise one number to another number's power, the model should find that and use that. We'll see if it does. I'll just restart it. So what is it? What is the cube root of, what was number 325, was it? 375. Forgot the question mark. Okay, it's wrong. That's wrong. Sometimes it gets it. So what if I say what is three? No, it hasn't used it. No, it's guessed again. What is 375 raised to the power of 1 divided by 3? Let's see what it does. Wait a minute. Is this calling anything? Should be, yeah, it should be calling it. What did I describe this as? Raise one number to the power of another. So that should have found it. Let me just make sure it restarted. I think I restarted it.
Do the descriptions make sense for 2 parameters?
I hope. The first number, oh yeah, you're right. Yeah, good point. Yeah. The number to be raised to a power. Good spot. I was careless. The number, the power to raise the number by. Good spot. So let's run that again. Was it 375? Yeah, right. What is the cube root of 375? I'm hoping it'll call that. Now it's calling it 7.211. It's correct. So it's got it that time. Good spot. Yeah.
Understand how it got the square root of 2 from the back.
I think it's just so common. So it'll be in every maths book. So it's so common.
Just invokes the multiply.
Yeah.
How on earth do you get that?
Yeah, and that made no sense. So it looked like it had called the multi.
What it threw into it.
Yeah, I mean, you could breakpoint it and see exactly or add some logging in there. It really is, yeah, because sometimes it calls divide. I thought it was going to say, what is 375 raised to the power 1/3. I'm wondering if it's going to call, I was hoping it was going to call the divide method to do that. Power, no, it's just, it's got it right.
It just knows what a third is.
Yeah, what if I said,
Apologising to you before doing.
yeah, it is very apologetic, and I think divided by,
Press the apologise for the error in the previous.
yeah, I actually had it when it was doing, one time I ran it, and it was doing the lamp, and it was switched, I'd say, make the lamp turn blue, it would say, I'm sorry, I can't help you with that. I'm so useless. And then turn the lamp blue anyway. And said, and I've turned the lamp blue. And I said, it's totally fine, carry on. Thank you for your understanding. And they kept on apologizing. And I think there's something in the system, what do we put the system prompt here is, where's, oh no, this is, so maybe if we just do something like, keep this simple, this seems to be, I've disabled it for some reason. If the user doesn't provide enough, let's just, yeah, let's see if that might make it a little bit less sort of obsequious. Let's do a different one. Let's use that, the database thing one. So what is the length? I mean, you wouldn't use a dictionary object, you'd go pull it from a database or something. What is the length of the model N20G? I can't remember what these models are actually. Then that should figure out that it wants me to, so 4.6 meters, let's check. So that should be the N20G model is indeed 4.6 meters. And we can say, what about the S12R? So now it's got the context. It knows I'm asking about lengths. So I don't have to tell it again what's the length of. But we can also do something like make the lamp the color of the, which I can't remember which one's got a sensible color. The Neptune. Of the Neptune. It should make it blue because it's the lamp has been set to the color of the Neptune, which is a blue color. So all we've done is all we had to do to get all this magic to work is in here I said auto invoke kernel functions, and I added the plugins to the builder, and then the semantic kernel does all that, you know, converting it onto JSON, sending it to the large language model. The large language model then uses the function invoking mechanism to call the function correctly at the right and make all the assumptions and deduce, okay, because it actually made it call two things in order to answer that question. I think we actually we called the light on, and I don't see where it calls the. Oh, I didn't even say color. It didn't even spell color right. So it definitely doesn't worry about English spelling. It doesn't worry about any spelling.
Might explain the duration length is significantly longer.
Yes, but I don't see it calling the model function, which was get color, I think. And that's
does the length function also bring back? I'm just trying to picture in my head what the full context was when it, because it's going to have the full function output presumably of the previous functions.
Yes, yeah, it's got the history. It might have got it from the history. Yeah, it might have done. So if I started again, yeah, it might actually call that.
Or is Neptune the planet?
That's a good question. That's a good question. Yes, that is a good question. So, because it is kind of bluish, isn't it?
Yeah.
That's I like. Yeah.
Got two Neptunes as well.
Yeah.
It didn't
Oh yeah, I should have said the N20G. That's what I should have said. I should have said make the lamp the color. I think that's what I meant, of the N20G. I think actually that might explain it. Function color. Yes. So that it caught. That's it. You're right. Yeah. So it went to the color, got the color, and then it went to light on, and we can just double check that because it was blue before. What was Saturn? S12R is the Saturn, so we'll say the S12R, and it's gone red, so that's correct. And if we make one up, S13X, no such. I couldn't find the color information on the S13X model. Could you provide me with another model SKU? So it does a pretty good job of figuring out what this this model thing does. So I think let me go back to the slides. So that was what's the cube root of. You can also, and I won't do this, but you can also do things like you can use semantic kernel instead of, when you've got your plugins, you might actually be calling another agent. So you could have a number of different agents that do particular jobs. So you might have a small language model that's been fine-tuned to do some particular job, like medical knowledge or something in some field or something like that, specialist field, and call that as a through an API, through a plugin. That's you might have some custom algorithm that you use. So that's a small language model. Call some data, and then and perhaps different large language models that are optimized for different jobs. It's very expensive to train though, or to fine tune a large language model. But there's small language models. Microsoft have one called Pi, isn't it? Is it Pi? The Phi, not Pi. Phi, different Greek letter. The Phi small language module, which is actually very good, and it's only been trained on sort of textbooks and things like that, rather than being a much bigger corpus that a model like GPT-4 has been trained on, for example. So various ways you can combine these things. One last thing we can do is, if we've got time for one last demo. Would you like another demo, or do you want to go to the pub? Demo? So we will, in that case, I will stop this one. And I'm going to go to, so this is a demo that you can get on GitHub, and it was AI demo solution. So it's this is one that James Montemagno has built. I cloned it down onto here. This is one where he has done it as a web application, and then a little sort of client front end. So the client is just called is HTTP client, localhost 5171, and sends requests and bounces them back. And then this application here is a web application. This uses the web application builder and then adds the kernel. So builder services add kernel, and then he changes them. So he says add Azure OpenAI completion, and then I've substituted with my model GPT-3. I think that should be GPT-3.5. I think I'll just leave it. I know this works. I think that should probably be GPT-3.5 as well. But anyway. I tested this before and it worked, so I'm not going to change it. One thing I did have to do is what it does, it does the app builder, and then it reads a file. So it reads all, popping up everywhere. It reads this tensor primitives netcore.cs, which is this massive code file here, 20,000 lines. I'm not Uncle Bob, but I would say that's a bit on the long side for a file. But there you are. It's a tensor library, and he's just using that as a big chunk of code so you can ask questions about it. So to do that, we're going to use the RAG. I mean, all of these really are the RAG model. So Retrieval Augmented Generation isn't just some complex semantic index that you're using, like Azure AI Search. Just anything, something you've already built, you can use it as a plugin. If you can call it, you can make a plugin out of it. But this one will read all this code, convert it to an array. I added this take 5000 because I just found that the copy of the embedding service, remember these embeddings are these big vectors for each, contain the meaning of a particular word in a particular context. And then it's taking that embedding. I just, as I say, just took the first 5,000 lines because it wouldn't. I didn't want to. I was basically too mean to pay for a premium subscription to get it to load them all, load the whole file, and then it calls a tokenizer, splits it into chunks, and then it does a semantic comparison so that when you ask a question, it'll find the part of that big code file, that 20,000 line code file, that's relevant to the question, and then feed that into the prompt. So this is a type of, well, exactly, it is Retrieval Augmented Generation. So once it's done that, it's going to then get the chunks and then push those into the large language model. So let me just run that. And what was I don't remember the name of the function I was going to ask it about. It was, wrote it down here, not that one, not that one. Here we go. Is this thing running? Okay, that is the web application running. I also need to run the client. I probably should have set up the startup to do this, but it's okay, I'll just do that now. So I've got, what have I got? I've got that running on port 5171, and I'm going to call on port 571. And I'm just going to say, what can you do? And it says, oh, yeah, you give me some code so I can ask questions about it. This is what it seems to be, this code. It's a vector, it performs vectorized operations. So I can say, what does the cosine similarity core method do? Computes the cosine similarity between two non-empty equal length tensors for a single precision floating point number. Sounds reasonable. I think that's basically what we're using to do the semantic search into that document. So this is all, that bit's local, the RAG bit's local, but the large language model is GPT-3.5 that it's calling, which is actually in Azure OpenAI. What is the function of the aggregate method? So I got my own mini GitHub Copilot here that's analyzing code. What was the prompt? It was, please answer this question. Very basic. The prompt is, please answer this question, and then the actual question. So this is what I typed in. What is the function of the cosine similarity thing? And then it does star, star, star code. That's sometimes helpful. It's just sort of a separator that the language model knows usually means there's some content coming that I'm supposed to look at. And we call that grounding. It's grounding its response in that. So if I didn't provide that chunk of code, which is relevant to the question, it would just go off and start making stuff up probably, and wouldn't be very useful. So that's a great example of using the RAG model. That is there. If you want to download it and try that one yourself, it's here. We'll make those slides available later as well. Okay, so that's that one. But as I say, this is just an example of chain of thought. We saw this where we did it with the trying to get it to do the right colour for the football shirt. So that's really just to wrap up. They're kind of co-pilots, not autopilots, but we would like them to do things for us. So making them agents means that they will actually go and do something rather than simply answer questions. I don't want my Outlook Copilot to say, you could paste in this into a response. Just send the email, really. Let me approve it first. So we should certainly ask the user for approval before we do anything of consequence. But we want to go further than just answering questions. The plugins, very powerful. We can just integrate all kinds of things into these and come up with very sophisticated solutions that do things in response to questions and have relevant information. So we're going to go beyond chatting. We might combine models as well, so that can be just from purely an efficiency point of view, rather than just throw everything at a large language model like GPT-4, which is really expensive. Use something like perhaps GPT 3.5 might be good enough, or Phi. There might be an order of magnitude less expensive to use those models if they can do what we need them to. So it's the new industrial revolution, rather than as in the industrial revolution we had steam engines to do work that we couldn't do with our bodies. We're probably getting to the point where we can use the power of these models to do things that we just wouldn't have time or wouldn't want to do with our brains. Of course, there are some downsides to all that and some existential risks, so that's a topic for another talk. So that's about all I have to say. I would encourage you to try this and experiment with it. Hope it's interesting. If you could possibly scan this or use the AKMS Attendee Survey Season of AI, they're running a pilot, so Microsoft would be interested to know your opinion of these talks. That would be great. And they did give us some socks, so and there's some links as well. So that's pretty much all I have. I hope that was interesting, and thank you very much.